Hello everyone. In this lecture we'll see module number 1, calculus of complex function and construction of analytic function. So firstly we'll see the introduction of complex function and we'll see the basic concepts and properties of complex function here. So firstly we'll see the introduction part of the complex number. So in this introduction, so here we'll see a real valued function, which is nothing but y is equal to f of x. Fine. And we introduce a complex valued function. Here we'll introduce what here? Complex valued function, or complex value number also we can consider here, or anything. So complex valued function is nothing but we are going to introduce as w is equal to f of z. So real valued function, you can see that it is y is equal to f of x, and here w is equal to f of z is what here? Complex valued function. So here I can say that, so here this is a function of a complex variable z, because here z is complex number, and you know that z is always given by x plus iy. So we'll see that detail now. So we'll consider that one in the form of basic concepts. So what are the basic concept? We'll see here in this complex function. So we know that, so z, which is a complex number, it is always given by x plus iy. So z is equal to x plus iy is a complex number, and where this x part, where x and this y, the variable x and variable y are real numbers, and I can say that x is always called a real part and y is called what here? Imaginary. So here x is called a real part of z and y is called imaginary part. Okay, because I is there with coefficient of y is I here, so imaginary part of z. So these are the very important things. So x is equal to x plus iy is a complex number where x and y variables are real numbers, and here the first term which is free from I is going to called as a real part of z, and y, which is coefficient of y is I, so that's why y is called imaginary part of z. So you have to remember these things, very important. So next, one more thing. So and always I is nothing but root of -1 or I square. If you square this one, so I square will become -1. These two values you have to remember. So whenever it is required, so we have to replace it. Either root of -1 is going to be replaced by I, or I will be replaced by root of -1, so depending on the situation of the problems here. Also I square is nothing but what here? -1, or -1 is also going to be replaced by what here? I square here. So these are the few important things we need to remember. Next, very important point here. So this we have seen, this is the first point we have seen here. So second point in this we'll see as z is equal to x minus I y is called, means you know that we have taken z is equal to x plus iy. So if you change the sign, so it is going to be called as conjugate of that. So here we can say that z is equal to x plus iy is called complex conjugate. Complex conjugate. Okay, it is called complex conjugate of z. Better we'll take. So x is equal to, or sometimes it is going to be denoted as z bar also. So z bar also is sometimes will take, or z also if you take, so no problem. So here, so these are the few very important things here. So next we are going to consider here few of the results, like we have the series result for e raised to x. We'll see here. So e raised to x, it is given by 1 plus x divided by 1 factorial plus x square divided by 2 factorial plus x cube upon 3 factorial plus x raised to 4 upon 4 factorial plus so on. So this result already you have calculated using Maclaurin series and all. So similarly, e raised to ix, so this is a complex number, e raised to ix, it is also given by 1 plus x is there, so we'll write ix upon 1 factorial plus x square is there, so at that time I square x square upon 2 factorial, x cube is there, so at that time x cube I cube x cube divided by 3 factorial, x raised to 4 is there, so I raised to 4 x raised to 4 upon 4 factorial plus so on. But further, e raised to ix, we can simplify this. So because ix, so I square, so you know that I square is nothing but what here, minus 1. So I square will be replaced by minus sign. I cube, so if you consider here, so I cube is nothing but minus I cube is nothing but, because I square is what here, so I cube can be written as what here, I square into I, so I square is nothing but minus sign and I, so it will become what here, I cube, you have to remember, so it is nothing but what here, minus I. So using these all, we will go for the simplification of this. We'll see the simplification. So we'll see here now on simplification of this 1 plus, so we can't make any changes in this, so it will be ix upon 1 factorial, so I plus I square will make it as minus 1 into x square divided by 2 factorial plus I cube will write it as minus I into x cube divided by 3 factorial plus, so I raised to 4 we can make it as I square into I square is minus 1, one more I square is minus 1, minus minus plus, it is only x raised to 4 upon 4 factorial plus so on. So on separating this, so what is the separation here? So we'll take free from I one side and with I one side. So before that I will arrange 1 plus ix divided by 1 factorial, so plus into minus is minus, so x square by 2 factorial, so minus plus into minus is minus I x cube by 3 factorial plus x raised to 4 divided by 4 factorial plus, so here you can just predict it, so ix, so here x square, so which one is having a even number, so we'll get means even power, so we'll get only x to the power that, but for odd we'll get minus I will get. So next is x raised to 5 means we'll get minus I into x raised to 5 upon 5 factorial Next expected is what here? Plus x raised to 6 upon 6 factorial. Next is minus sign will come, so on. So on rearrangement, so what rearrangement I want to make here as, so free from I, so free from I terms are 1 minus x square. So here so here what happens here, we'll get minus sign for this, okay. So on simplification, x square by 2 factorial. Next free from I is plus x raised to 4 upon, why it is minus sign? Because I raised to 6 means what here? I square into I square into I square. So minus 1 minus 1 minus 1. So it will become minus minus plus, plus into minus is minus. So that's why it is minus sign here. So x raised to 4 upon 4 factorial. Next one is, so on simplification of this, so x raised to 4, after the x raised to 4 free from I is minus x raised to 6 upon 6 factorial. Next plus sign is expected here, okay. So that is one side, so on. We'll make one bunch here, another bunch. So another bunch you will take with I, so plus sign, and we'll take I common. So among this, if you take I common, x divided by 1 factorial. Among this we have taken I common, so minus x cube divided by 3 factorial. Among this you take I common, so minus x raised to 5 divided by 5 factorial minus so on. So in this way we have to arrange for this. But remember, so here what happens, first bracket what we have, it is a series for cos x. So plus sign I times, so this bracket x upon 1 factorial minus x cube upon 3 factorial minus x raised to 5 upon 5 factorial, it is series result of sine of x. So e raised to I x, we can write it as cos of x plus I times sine x, where cos of x is a real part, sine of x is what here? Imaginary part here. So this is you give as equation number 1. Similarly e raised to, here e raised to plus ix is a e raised to minus ix, we can write it as conjugate, that is cos x plus will become what here? Conjugate is minus I times sine x. You have to remember these results. So e raised to ix will be what here? Cos x plus I sine x, and e raised to minus ix is what here? Cos x minus I times sine x. So both are useful. Either cos x plus I sine x can be converted as e raised to ix, or e raised to ix is what here? Cos x plus I times sine x, or equation 2 also in the same way. Now write one of the important result by using 1 and 2. So on adding 1 and 2, so what happens we'll see. So left hand side will add with left hand side. So what is left hand side? So e raised to ix plus left hand side of 2 plus e raised to minus ix is equal to right hand side of 1 plus right hand side of 2. That is, right hand side of 1 is cos x plus I times sine x, plus right hand side of 2 is cos x minus I times sine x. But you can observe here, so plus I sine x and minus I sine x cancel. So cos x plus cos x is what here? 2 times cos x. Or we can make this one as one of the important result for the problem as, so e raised to ix plus e raised to minus ix, you can make a formula as what here? 2 times cos x. If you get a situation to convert in terms of trigonometry, so e raised to ix plus e raised to minus ix can be written as 2 cos x, or cos x is equal to e raised to ix plus e raised to minus ix divided by 2. You can make one more formula here. So please do remember this, and I will make this as formula number 3 here. Either you can make this formula or this formula, both are very important. And similarly we'll go for one more option here. So subtracting 1 and 2. will get as, so on subtraction, on subtraction 1 minus 2, so what will get here? So left hand side of 1, that is e raised to ix, minus left hand side of 2 is e raised to minus ix, is equal to right hand side of 1, that is cos of x plus I times sine of x, minus, I will put a bracket, right hand side of 2 is bracket I will take because of minus sign, so cos of x minus I times sine of x. So on simplification, cos of x plus I times sine of x minus cos, open the bracket, minus cos x minus minus plus I times sine x. So on simplification, plus cos x minus cos x cancel, I sin x, it will become 2 times I sin x. So you have to remember one more result here. So e raised to ix minus e raised to minus ix will be considered as, because of minus sign, it will be converted as what here? Minus 2 times I sin x, or we can make this one as, or we can make it as what here? Sine of x is nothing but e raised to ix minus e raised to minus ix divided by 2i. You cross multiply this, it is 2i. So sin x formula and cos x formula. So result number 3, result number 4. So you have to remember and see that it is a one of the very basic concepts of our this complex function, and which is most useful formulas like z is equal to x plus iy, and z bar, that is conjugate x minus iy. Then we can take it as what is e raised to x, e raised to ix, that is cos x plus I sin x. Then what is e raised to minus ix, that is result number 2, cos x minus I sin x. Then using 1 and 2 we got the important results as e raised to ix plus e raised to minus ix is nothing but 2 cos x, or cos x is nothing but e raised to ix plus e raised to minus ix divided by 2. And on subtraction we got one more important result, e raised to ix minus e raised to minus ix is equal to we got 2I sin x. How this result got, that I have shown you, but you have to remember the result. So result number 1, 2, 3, 4, these are the very important results here. So whatever we have seen, so completely it is in the form of Cartesian here. So we have a similar case in terms of what here, polar also. So these are the few basic concepts for this initial function, that is I can say that for the complex function. So now we know that so z is equal to x plus iy is a complex number, but this is a complex number in Cartesian form. Okay, so means Cartesian form means in terms of x and y. So similarly, so I want to define for polar form also. So complex number in polar, we'll see complex number in polar. So here complex number in polar, it is given by, so z is equal to r into e raised to I theta. So actually this is proved by using De Moivre's theorem, so I will not go for that in detail. So you need to remember, so z is equal to r into e raised to I theta is a complex number in polar, is a complex number in polar form. So polar form means always it is in terms of r and theta. Variables will be in terms of what here, r and theta. Cartesian means in terms of x and y. Polar means in terms of r and theta. So where I will just describe here, where r is nothing but square root of x square plus y square, and theta is nothing but tan inverse of y upon x. So we call it is usually it is called tan inverse, theta is nothing but amplitude, so which one already you have seen. And next you can detail and all we'll see, means symbolically we don't want right now, so just you have to remember. So what is polar form of the complex number? That is z is equal to r into e raised to I theta. So with the help of these all basic concept and the definition of this our complex number in terms of Cartesian and polar, so we'll see the actual concept, what is complex variable functions, their derivatives, and which kind of situations we are going to face in detail, we'll see in the next lecture.